Okay, I'm saying we're defining the regions of a set, and we said where this A is, the small a, where this small a is where we call this one, they can say it is the region of A only. This is region of A only. This is the region of A only. But in set notation, they can say this region is a region of A intersection B complement intersection C complement, or they can say A but not B and C, or A but not B but not C. They can use those terms there. So you need to know how to define the regions of the set. Then also B only, they can also do the same thing. You notice that the complement is on A and C but not B. So we're saying this is, they can say B only, or they can say it is A only, but not, they can say B but not A and C, or B but not A but not C, anything like that. Then C only, the same thing, it is the region G. Now if we were going to look at those things later on. Now if they say A and B is a region B plus D, we introduce this. This is the region of, you know, so this one here is the region of B and D. That's why the set of A and set of B are intersecting. They are represented by B plus D. And that's what they say, A intersection B, that's how we say. Then B and C. B and C is D plus F. That's why the set of B and set of C are intersecting, D plus F. Then A and C is still the same thing. A and C. A is here, C is here. The intersection of the two is this circle. D and E represent that section. Then the last one, not the last one, they can say A and B only. A and B is different from A and B only. Now, A and B, the whole of this is the A and B. Is the A and B, but A and B only, you remove C, you remove anything to do with C, and you'll be left with only this small b here. So in using mathematical notation, we can say A intersection B intersection C complement. You're removing anything to do with set C, so you'll be left with only B. They are intersecting, A and B are intersecting here, but where do we have A and B only without any mixture from C? That is the region represented by B. They can say A and B, but not C. That's how they can write it in words. Then lastly, B and C only, we still use the same argument. A and C only the same argument. Then the last one, the other one is A complement intersection B complement intersection C complement. We say this is the same as A union B union C complement outside, like that. And this one they can say none of the three events. For instance, you are 40 in class, you're dividing all yourselves amongst maybe the different games. You say those who play volleyball, those who play netball, those who play football. Then you find the three who do not play any of them. This is the region that is represented by that. And according to our Venn diagram, it is region H outside. So if you understand these regions very well and the terminology is used, I'm sure resets won't be a problem. Now I've given you, this is the first example. This example we're looking at. Let's follow it very well because we're using it basically to understand the regions of a set of three sets. Now the very first example is here. This example one. Example one, we're saying that in a Venn diagram, this is the Venn diagram we're dealing with. The universal set, remember we defined these symbols. This is for universal set. The universal set is representing the cars in a given split. Maybe you go to Kampala splits and you look at the cars there. Cars in a given split. This can be any split, maybe around Kampala or anywhere. So We're looking at cars in a given street. Let me pick another pen. Cars in a given street. Let's say this is our universal set. Now the first question is saying, of course, we have B is representing blue cars. So you go to a street and look at the cars which are there. B is representing the blue cars. Then L is representing cars with left-hand drive. I think you know there are cars, some of them, the driver can sit on the left-hand side, others, drivers can sit on the right-hand side. So L is representing cars with left-hand drive. Then F is representing cars with 4 doors. Of course, we have cars with 2 doors. We have cars with, now like double cabin double cabin car has 4 doors. Then those are single cabin, I think. That's the opposite. Single cabin will have 2 doors. So this one was interested in cars with 4 doors. And he came up with this Venn diagram. We have set B. This is what he has. Remember, set B is represented by the whole circle. This whole circle. If you want to find cars represented by the number of cars represented by set B, the whole of this circle. Then set F. F, these are 4 doors. Those ones is so with 4 doors. We have that. Then those ones, the left-hand drive, where the driver sits on the left hand. We have that. So the first question says, how many cars are blue? How many cars are blue? Can I have the responses? We're discussing this because we want to get to know these terms very well. How many cars are blue?
10.
How many?
8.
There are 8 cars which are blue. Now I'm putting more problems this way. Let me undo what I'm doing. So there are 8 cars which are blue. You just count the number of stars, the number of crosses in a given circle. So here we have 8 cars. If I can count 1, 2, 3, 4, 5, 6, 7, 8. Yeah, there are 8 cars which are blue. So we shall have 8. I'll just write here 8. Because creating space is going to mix up with the other one. So we shall put here 8. There are 8 cars which are blue. The same of asking that question using the same notation that I've said, find the number of B. So the cars which are blue, in this case, we know that there are 8. The next question is, how many blue cars have 4 doors? How many blue cars have 4 doors? Remember the definitions. B is for blue cars. F is for 4 doors. So how many blue cars have 4 doors?
Five.
How many blue cars have 4 doors? That's what we're looking for. Hey, what have I done? I clicked on something here, Mr. Okay. Yeah, somebody was giving me the answer in the inbox. So, am I still sharing screen?
No?
No, sir.
Okay, let me share. I think I'll share screen. So, how many blue cars have 4 doors?
Check 2.
2. So, yes, Ezra. Ezra, you raised your hand?
2.
2. So there are 2 cars. There are 2 blue cars with 4 doors. In simple terms, they're asking for the number of B intersection F. The cars that have blue doors and they also have 4 doors. I mean, have the number that are blue, number of cars that are blue, but they also have 4 doors. So according to our Venn diagram that we looked at the beginning, A intersection B is represented by the whole of this circle here. So it is B plus B. But when I come to this Venn diagram, I noticed that we don't have anything here. What we're looking for is this. What they're asking for is this area. The B intersection F. You notice that there are only 2 crosses in that section. That means that the number of blue cars that have 4 doors are only 2. That is, I think, understood. So this is equals to 2. Then the other one is, how many cars with left-hand drive? How many cars with left-hand drive have 4 doors? Yes? How many cars with left-hand drive have 4 doors?
3.
Somebody's giving us 3. Number cars with left-hand drive that have 4 doors. So I look at the intersection here. Left-hand drive and 4 doors. This is a set of left-hand drive and this is a set of 4 doors. And yeah, left-hand drive is this one, then 4 doors the other. So when I shade, I have this region, the one I'm dealing with. And how many X's are in that region? There are 3 X's. So the number of cars that have left-hand drive and 4 doors, there are 3. So the number of cars with left-hand drive intersection 4 doors, there are 3 cars. Then how many blue cars have left-hand drive? How many blue cars have left-hand drive? George Washington. How many blue cars have left-hand drive? Yes? Ezra? We can't hear you, Ezra. We are looking for the number of blue cars with left-hand drive. We can't hear. Maybe try to unmute yourself. We can't hear you. We join with. How many?
3.
There are 3. The number of blue cars. We're now looking at blue cars and left-hand drive. The intersection of the 2 is this. So I simply count the number of stars in that region, and you realize that there are 3. They are simply asking for the number of blue cars with left-hand drive, and these are 3. Then how many cars are in the street? How many cars are there in the street? Ariho? How many cars are in the street?
So there are 18.
There are 18. You simply count everything inside this rectangle. You'll find 18 because they're asking for the number of elements in universal set. So are they 18? Let's count and see. These are 5, 8, 10, 12, 18. Yes, they're 18. They're simply asking you, the other way of asking this is find the number of B union. In fact, not even that, because that one will give us what is inside the sets only. So they will simply ask for the number of, the number of the universal set, number of elements in the universal set. How many blue cars with left-hand drive do not have 4 doors? How many cars? Yes, Ezra?
Teacher 1.
1. They're saying how many cars with left-hand drive do not have 4 doors? So I'm going to look, the set we're talking about is this one. Number of cars with left-hand drive that do not have 4 doors. Number of cars with left-hand drive that do not have 4 doors. So notice that how many cars have left-hand drive? The number of cars with left-hand drive, 1. Let's mute ourselves. The number of cars with left-hand drive are 1, 2, 3, 4, 5. Those are the number of cars with left-hand drive. There are 5. Now, how many of these ones don't have 4 doors?
2.
There are 2. There are 2 cars. There are 2 cars with left-hand drive that do not have 4 doors. You notice that all these ones here, all these ones have 4 doors. These 3, but now these ones are the ones. You notice that this one and this one is not in touch with any of this set. They are outside this set. So number of cars with left-hand drive that do not have 4 doors are this and that. There are 2. How can you write this in set notation? How can you write? Yes, Ezra?
Excuse me, sir.
Yes, please.
They said how many blue cars with left-hand drive do not have 4 doors?
How many blue cars? Hey, we have left out this. How many blue cars? The car has to be blue also. It has to be blue. So we're supposed to take this here. That is a good observation. That's a very good observation. Because if that said how many cars with left-hand drive do not have 4 doors, it will be right by giving the 2. But now if they're saying how many blue cars, the car has to be blue, it must have left-hand drive, but the only missing thing should be the 4 doors. So that means that we take only this one. Because this one, yes, it has a left-hand drive. It doesn't have 4 doors, yes, but it's not blue. This X here, I've even deleted it. This X you're seeing here, this one has left-hand drive, that is correct. It has, it doesn't have 4 doors, that is correct. It meets the last 2 conditions, but it's not blue. Then this one here has a left-hand drive, yes. It has, it doesn't have 4 doors, yes. And is also blue, so it meets all the 3 conditions. That's why we take 1. That's a good observation, Ezra. That's what we have here. So what do we write? How can we write this in set notation?
L intersection B intersection F complement.
L intersection B intersection F complement. Yes, that is very correct. Number of that. Number of cars with left-hand drive and blue, but not, but they don't have 4 doors. And this is 1. Yeah, that's how we answer that question there. We're just using this to make sure we understand the regions very well. Then we shall go to more detailed questions. Let's now also have this last one, the second one here, where they've given us the same figures, but not stars. Okay. Just a moment as I try to retrieve my work. This is our universal set. So the universal set is representing number of houses in the street. C is representing houses, house with a central heating point. You know, we have those houses, most of those in winter, those conditions, they have heating points in them. So they are saying house is central heating point. Then L is house with a TV, a color TV. Then F, house with a garden. That's what we have. That's what those symbols are defining. Now, when you're dealing with sets, make sure you define symbols. You define questions where they are not defined for the symbols. You define them before you start. So in this case, they are defined for us. They're saying the inverse set is representing the number of houses in a given street. C, houses with central heating point. L, houses with color TV. And F is house with a garden. So the first question is, how many houses have gardens? How many of those houses have gardens? We're answering this together. How many of the houses here have gardens? Yes. You look at the circle for the gardens, then get us the number of houses with gardens.
59.
59 houses. When I look at this circle of the gardens, this is 40, 51, plus 8, 59. The number of houses with gardens, they are 59. Then how many houses have color TV and central heating point? Color TV is this, central heating point is that. How many houses are in that region? Mugisa, Paul. How many houses have color TV and central heating point?
11.
The 11. This is the region for the 2. So there are 11 houses. Number of color TV intersection central heating point. Then how many houses have color TV and central heating point and a garden?
5.
There are 5. They're looking for the intersection of the 3. How many houses have a garden but not TV or central heating point? This
40.
They have garden but not TV or central heating point. They are 40. They have the garden but not TV or central heating point. So they are 40, yes. How do you write this? In set notation? How do you write that using set notations?
G intersection T complement intersection C complement.
G intersection T complement intersection C complement. This is the number of those that have G gardens, but not this and the other one. So we have this equals to 40. The other way of writing this, remember we said somewhere in 2 sets, we said T complement intersection C complement is the same as T union C complement, something like that. So here you can also write this as, this is also the same as the number of G intersection T union C complement, like that. These two are the same because you notice that they are using even O here. O in most cases use O means union in sets. So if they say how many houses have gardens, but not, this but not is now the complement here, but not TV or color TV or central heating. So we can write it like this, you can also write it like that. The two are acceptable, they are correct. So the other one is how many houses have TV and garden but not central heating point? How many houses have TV and garden?
86.
They have TV and garden, but not central heating point. TV, somebody said
86.
86. How do you write that in set notations? Number of How do you write that? Somebody saying 86, do you concur with it, with him? Because he's saying, they are saying how many houses have TV and garden? No? They have TV and garden, but not central heating. TV and, that is TV intersection garden, you know? TV and garden. When you go to a house, that house must be having a TV and garden, but the only thing they're missing is central heating. That's what they're trying to tell us here. TV and garden, but not central heating. Can somebody tell us that? Tell us how we write that in set notation. Maybe that will help us to visualize which area we're dealing with. Can somebody tell us that? We are trying to make sense of the definition of religion. Yes, Ariho?
G intersection T, intersection C complement.
Intersection C complement. We have G and T. A house has TV, yes. It has a garden, yes. But the only thing they're missing is central heating. How many houses have TV and garden, but not central heating? How many are they?
11.
There are 11.
11.
There are 11. Now, when would this 86 be correct? Who can tell us? Who can modify for us this question so that this 86 is correct?
How many houses have a TV or a garden, but not central heating?
Perfect. TV or a garden, they have either of them. You go to a house, it has a TV or a garden, or even both, but not central heating. So you can go to a home and they have only TV, yes. Or you go to a home and they have only garden, yes. Or you go to a home and they have both TV and garden, yes. But the only thing they're missing is central heating. So that's how we write it. 86 would be correct if they had said they're asking for number of TV or garden, but not central heating. T union G intersection C complement. Yeah. That's when that 86 would be, that would give us 86 as the correct answer. How many houses are there in the street? Yes, Ezra?
There are 124.
124. Number of the elements in verse set are 124. Yeah, you can count. This is 20 plus 14, 34 plus 40, 74 plus 11, 85 plus 35. Well, did they come up? Yeah, there's a 20 here. Okay. There's a 4 comes out. So this is what we have. So that's how you answer that. So lastly, I'm going to share one here, and after sharing this, after sharing it, we finish up with this. Then I take you now to UNEB type questions. We're doing this just to understand the regions very well. Do you have any questions so far before I even proceed? Can I have questions? Make sure you ask questions when in such classes. In case there's a concept that you think you've not gotten very well, you can ask and we review it before we proceed. If there isn't, let me bring in. So let's try to interpret this number together. This is our example 2. These are the questions now you're going to find in papers. Such questions. The other one, we're just helping us to learn how to interpret, to get to know understand the regions. Example. This is example 3, I think. Example 3. Now, you try to read, you read the question, then you try to break down the information together. We summarize the information together. The question says, a teacher told his students to come with a graph book, a mathematical set, and a calculator. In a class of 50, 2 did not bring any of the 3 items. Now we should know how to write that inset notation. In a class of 50, 2 did not bring any of the 3 items. 3 brought G only, 5 brought S only, 4 brought G and C only, while 5 brought all the 3 items. Those who brought G and S only are 3 less than those who brought S and C only. Yeah. And 3 times those who brought C only. Can somebody tell us? That's now like some bit of logic for us, and this will take us through the remaining time. Want to write this in set notation. Solution. What do? We start by summarizing. When you're doing you're doing sets, the first thing you do is summarize the information given, and you write that information. You write it in set notation. So the first one is they're saying in a class of 50. That means that the universal set you're going to deal with has 50 students. The universal set has 50. That's what we write. Then 2 students did not bring any of the 3 items. Who can tell us how we write that? How do you write that in set notation? 2 did not bring any of the 3 items. How do you write it?
G union M, G union M union C complement.
Union C complement outside, isn't it?
Yes.
And we said this can also be written as number of G complement intersection M complement intersection C complement. These 2 are the same. Why we have complement outside? Unions. When you bring it inside, they become intersections. And this we say it is the same as 2. Then the other one is 3 brought G only. 3 brought graph books only. How do you write that in set notations? Number of how do you write that?
G intersection M complement intersection C complement.
Intersection M complement intersection C complement. And this is the same as they're saying 3. There are 3. 3 brought, yeah, there are 3. Then next, they are saying 5 brought S only. That is also the same as S intersection G complement intersection M complement. There are 5. Then 4 brought G and C only. 4 brought G and C only. How do you write that? How do you write that? Okay, so we have G intersection C intersection M equals to 5. Then what else? What else have we been given? Those who brought G and S only are 3 less than those who brought S and C only. How do you write that? Those who brought G and S only, I think that's how we write it, are the same as what? Are 3 less than those who brought S and C only. Are 3 less than. How do you write that then? What's the relationship between the 2? If this is 3 less than the other one. Hmm? How do you write that? If
S intersection C
intersection
intersection G complement into brackets minus 3.
minus 3. Yeah, there are 3 less than the other one. You see, there are 3 less than the other one. So that means that if I add 3 to this, if I subtract 3 from the other one, that's when they'll be equal. I don't know that you get that. If you have some issue with that, then you maybe ask and I try to explain it more further. They are saying those who brought G and S only, that is G and S only, this is what they have, are 3 less than those who brought S and C only. So if you have let's say A and B, and they say B is 3 less A. What do they mean? Or A is 3 less B. That means that if I want to get B, I must add 3 on A. If they say A is 3 less B, that means that if I get A, to get B, I must add 3 on A so that they become equal. That makes sense. If maybe the 2 of you are sharing things and for you get 3 less than what your friend got, if you're sharing, you're 2 maybe sharing books, then for me I get 3 less the other one. That means that my books will be 3, will be fewer, will be 3 less than, they'll be less by 3 as compared to what my colleague gets. So in that case, to get what he has, I must add 3. Or I can subtract 3 from his to get what I have, something like that. So here they're saying G and S only is 3 less S and C only. That means that if I get S and C and subtract 3, that's going to be equals to G and S only. Does that make sense? Hello, the one who asked me to explain. Is it a bit clear now or you need more explanation?
Yes, it's clear.
Okay. So the statement is still continuing. They are saying, and 3 times those who brought C only. And 3 times those who brought C only. They're saying G and S only is 3 less than this one, but it is also 3 times those who brought C only. It's 3 times those who brought C only. So how do you write that? Can somebody tell us? We're trying to interpret this question. That's where sets are. The major effort should be put in interpretation. Then the others will be very easy. So if they're saying those who brought G and S only are 3 less those who brought S and C only. That one is interpreted. But then they are saying also that those who brought G and S only are 3 times those who brought C only. If we're sharing things, we're 2, we're sharing, and I get something which is 3 times yours. How do you get a relationship? If I get something which is 3 times yours, and let's say I have 9, what will you get? Hello? If we're sharing something, maybe sharing books, and I get 3 times what you have. Maybe let's say I have received 9. How many books will you receive?
27.
If I've received 3 times yours, if what I have is 3 times yours, that is simple term, 3 times yours. Let's say I have 9. How many books will you get?
27.
There's something not clear there. We are sharing books.
3.
You get 3. Yes.
3.
If mine is 3 times yours, then that means if I have 9, you have 3, because you have to multiply yours by 3 to get what I have. You know, if what I have is 3 times yours and you have 3, that means that mine will be 9. If mine is 3 times yours and you have 2, then mine will be 6. You have to multiply yours by 3 to get what I have. Now here they're saying the number of those who got G and S only are 3 times those who got C only. That means number of G intersection S intersection M only is 3 times those who got G only. 3 times those of G only, which is G intersection C complement intersection M complement, something like that. So at this point, whenever they give you a question on sets, this is very important. First, summarize the information in this format, because this will help you to identify the regions you're dealing with. So after this, that's when now you can go to the Venn diagram. But now this point here is what wasn't clear. We came very well this side, but here is where you're now getting lost from. And certain questions always involve such parts where they're saying the number of those who brought G and S only are 3 less. You must know that if the 3 less, less means subtracting, you know, are 3 less those of S intersection C only. So I get those of S intersection C only, subtract 3, that's going to give me those of G intersection S only. Then also here, they're saying, and 3 times those who brought C only. So I get 3 times, that means they're saying 3 times. In fact, now that's how you want it to sound like that, so that you get it very well. 3 times those who brought C only. So if I know those who brought C only, then I multiply it by 3 to come up with what I want. Okay, so this step is done. We're now going to the step of drawing the Venn diagram. I want to draw the Venn diagram and we see how to look like. So I go to my shapes. I want to get a Venn diagram. This is my Venn diagram. Since it's having 2 sets, 3 sets, I'll make it bigger. Let me pull it from here. Okay. It's not allowing to be pulled. There's no problem. Then I'll bring my sets. They have to be 3. This is okay. I don't know why it doesn't allow to be adjusted. Shape link. Then I bring another one, another set. It can start from here. The sets can't be adjusted. I don't know why. Then another one will start from here. Now these are my 3 sets. My charts are not uniform, but I have the 3 sets. They will refused to be adjusted. So this is what I have. I have my universal, the number of elements, the universal set, they are 50. That's what I start with. Then I have 3 events I'm dealing with. G, I have a mathematical set. I have, what was the other one? Calculator, like that. Number of mathematical sets. Mathematical sets, we don't know. We don't know the elements that are supposed to be there. That's what we have. Now, let's start filling. They gave us G only. G only, this is the region for G only. And they're saying G only, we have 3. Those are the ones who brought graph papers only. They didn't bring any other thing. There are 3. Then, how many brought brought S only, those who brought S is standing for what? Sets, mathematical sets. Those who brought sets only, they were, what is this S here? What is the S doing? What is S representing?
That's why I got lost, teacher.
We're mixing M and S.
In some you're using G, M, and C, then others use S.
We
So it
messed
became
it
very
up.
confusing when you read.
We messed it up already. Why didn't you tell me that we don't have any symbol? Because the symbols are defined here, we have G, S, and C. We don't have M. We don't have M. So this, where there is M, we're supposed to put there. Hope I've not misfired everything. Let me see. Hope I've not misfired everything. Those who brought G, S, G and S. 2 did not bring any of the 3. So here this is supposed to be S. We've messed up already. So this S, we have S there. Even this one is S. I'm deleting where we have M, where we see M. And now we have M and S all together. This is all mixed up. This is all mixed up. So we're going to start interpreting it together again because we messed up with the symbols. A class has 50 students, so the number of elements in the universal, there are 50. Then they're saying 2 did not bring any of the elements. So number of G, union S, union C, complement, which we said can also be written as the number of G complement intersection S complement intersection C complement. These two are the same, gives us 2. When you try to shade the regions on a set, in a Venn diagram, you always find that these 2 will represent the same region. Then number of, they said those who brought G only, number of G only, that is G intersection S complement intersection C complement. That will be the same as what? 3. Then number of the 5 brought S only, S intersection G complement intersection C complement. There are 5. 5, yes. Yeah, make sure you track what I'm writing so that in case I make any blunder, we check it out and we don't again waste time. 4 brought G and C only. 4 brought G and C only. So G intersection C intersection S complement. There are 4. Then 5 brought all the 3. Number of G intersection C intersection S. There are 5. Then those who brought G and S only, those who brought G and S only, that means that C is complement. They're equivalent to those who brought G and S. Those who brought G and S only are 3 less those who brought S. So there are 3 less. That means that you're subtracting. There are 3 less those who brought S and C only. So minus 3, that's what it means. Then S and C only. And 3 times those who brought C only. We can again say, since the same thing, there are 3 times those who brought C only. C intersection G complement intersection S complement. That's what we have. Do we have any question from there before we proceed? Any question from this summary here? If there's something you can't visualize, something you think I should explain more, then you can ask.
Excuse me, teacher.
Yes, please.
Excuse me, teacher.
Yes, please.
This step here, where we're saying those who brought G and S only are three less than those who brought S and C only. Is it okay if we put their unknown terms like X instead of writing this?
So now those unknowns are going to come in when you're dealing with the Venn diagram. We can now use unknowns. That's very fine. When you're dealing with sets, unknowns are inevitable. We shall have to bring them in. So we can now bring in and say, what can we do here? We can say, let the whole of this be the same as X. So this will be X, this will be 3X. Then what about this one? This one will be the same as, let's first get to that step. I want to bring it in when you're dealing with Venn diagram, when we've drawn the Venn diagram itself. So because we can't write the whole of this in a Venn diagram, it is going to be very big for us to put in a Venn diagram. So we have to find ways of breaking it down. So my Venn diagram, let me bring the Venn diagram. We have a Venn diagram like this. Then I put the three sets. Let me make sure they are balanced. Of that. Then there's supposed to be, then we have another one. Let it start from here. Oh. I'll delete it. Moment, please. I'll try to fill it around with this. It is still bullying me, something like that. Then I'll have another shape. I'll start from somewhere here. Let's just be like that. Okay, so we have G here, graph papers. We have sets here. We have, what was the other one? Calculator. Now they give us, let's put what we have. The inverse set has 50. It has 50. What else? Those who brought nothing, you know, and students are, you tell them to bring something, they come with nothing. Those who brought nothing, there are 2. Now this one, I don't know why it won't this. Want a calculator here, not symbol. This should be the region for the calculator. Yes, perfect. So this one has a calculator. Let me move this into shape. This one is for the calculator. Now we have 2 here, and then those are the ones who came with nothing. 3 came with graph books only. Then 5 came with mathematical sets only. Then these ones came with G intersection C but not S. Where do we write this? Do we write it here? Or will be G intersection C only? G intersection C only. This is the region for G intersection C only. There are 4. 4 brought G intersection C only. They are here. Then 5 brought everything. That's what we have. Now these other ones are all in terms of unknowns. We have to go ahead and look for the expressions. Now we're saying, somebody is saying we can use symbols. Yes, here we can now bring in the symbols. We can say, let what? We can say let X represent, what should X represent? Hello?
It should represent N into brackets G complement.
It should represent what?
S and C only.
Represent S and C only. If it is representing S and C only, let it represent S and C only. So that means that we shall have to remove this. Represent number of S intersection C intersection G complement. This is X. That means that my number S only is X. Where is S only? I mean S and C only. S and C only is this region, isn't it? This one. So this is my X. My X is here. This is S and C only. If this is S and C only, what will be in G and S only? If this is that, what would G and S be equivalent to in terms of X? What would it be equivalent to? Hello? Let's get it from here.
X plus 3.
Minus 3.
It is X minus 3. X minus 3. So we shall have X minus 3 here. Then what will be in C only? What will be in C only? Let's be faster. From this
3 into bracket X minus 3.
3 into brackets
X minus 3.
X minus 3, like that. Okay, let's try check it out from here, from this one here, from this one. From here we notice that X minus 3 is equals to from this one, I mean, from this one, we're saying the number of G intersection S intersection C complement is the same as 3 times the number of C only, which is G complement intersection S complement. We can just let them like this. This is equal to that. Now from here, we know that we've just found this one as X minus 3. So this will be X minus 3. That is my G intersection S only, is equals to 3 into C intersection G complement, I mean, yes, intersection S complement. Now, when I want this one alone to be the same as a third into X minus 3, that's how it's supposed to be. You get it? Hello?
Yes, I will get it.
Yeah, that's how it's supposed to be. You just use this relationship here. So it's not the same as this, is 1 out of 3, like that. So that means that here I have 1 out of 3 into X minus 3, like that. So I have my Venn diagram, and at this point we'll of course get marks for it. We get marks for the Venn diagram with unknowns. As long as you've used the unknown X very well, you'll get the marks for the Venn diagram here. Now, what else do they want us to do? After drawing the Venn diagram, find how many students brought each item. Each item, how many students brought G, how many students brought S, how many students brought C. Now here we know that if you add up everything in this set, you must get 50. Everything in this Venn diagram must give us 50, because the number of students in the number of students here cannot exceed again the number of students in the whole class. So you add everything. Let's try to do it. We shall have 3. Let me choose which pen, blue, black, black. 3 plus 4 plus 5. 3 plus 4 plus 5 plus this 5. I'm starting with the knowns first. Plus 5 again. Plus 2. Then plus X minus 3 plus X plus a third into X minus 3. All this should give us 50. Then what do you get here? This is B3, 7, 12, 19. This gives us 19. Is it 19? Yes, this is 19. 19 minus 3, that gives me 16. 16 plus, this is x plus x is 2x. Then plus, when I open up here, this will be a third x minus a third of 3, which gives me minus 1 equals to 50. So 16 minus 1 is 15. I'll have 15 plus 2x plus a third x equals to 50. I take 50 the other side, I'll end up with 2x plus a third x equals to 50 minus 15. So 2x plus a third x equals to 35. This comes here, this becomes 6x, 7x, 7x out of 3 equals 35. Then 7x will be equals to 35 by 3, 105. Divide by 7, divide by 7. What do I get? X will be equals to what? Is it 15? Hello, can you confirm that answer? 70, 35, yeah, it is 15. So X is, yeah, X is, yeah, X is 15. That means that according to my Venn diagram, this one here is supposed to be, here I'm supposed to be having 15. Here I'm supposed to be having, this is 15 minus 3, 12, 12 divided by that, this will be 4. And this one will be equals to 12, like that. Now, when they ask you the other question, they'll be very easy for you to answer. The other question they're saying, find how many students brought each item. Now, how many brought graph books? I add everything in this circle here. Those who brought graph books only will be 12 plus 5, 17, 24. There are 24 brought graph books. Number of those who brought graph books, there are 24. Number of those who brought mathematical sets, this is 20, 25, 37. There are 37. Those who brought, because this is 20, 22, 20, 25, yes, 37. Those who brought calculators only, number of calculators, no, not only. Those who brought calculators, we have 4, 19, 24, 28. 28. And you now found the number of students who brought each item. Those who brought each item, you could now know it. Then the other one is those who brought C only. Those who brought C only, there are 4. You can see it. Those who brought C only, there are 4. If a student is selected at random from the class, what is the probability that he brought at least? Now that one we shall handle it later on. It's bringing a lot of terminologies that we've not looked at yet. At least I'll build on that next time. So in the next lesson, we shall still do more set numbers around 3 or 4, and then you build on that. And I think after the next lesson, you can now comfortably, you'll now be in position to comfortably do questions on sets. Do you have any questions? Otherwise, this marks the end of the lesson. You'll go to my YouTube channel. The videos are there. Subscribe so that you always get notifications whenever I put videos. If you have any question, maybe you can go ahead and ask. Otherwise, that marks the end of today's lesson. You're free to sign. You're free to sign out. Maybe if somebody has a question. Any questions?